Hello friends, today we will continue our discussion on the feature scaling. And you must know, not all machine learning algorithms are affected by the variance of the magnitude in the features. But there are few algorithms where this variance is not affecting the estimation. They are random forest or like the decision tree algorithms. On the contrary, there are few algorithms where before estimation this feature scaling or the standardization or the normalization of the feature is must needed. For example, linear regression, logistic regression and the deep learning method. There are two broad techniques of doing the feature scaling at the column level, that is standardization and the normalization. We have already discussed standardization technique in our previous video. Today we will discuss about the column level normalization, which is also known as the MinMax scaling. This normalization method is actually rescaling the original value of any feature to a specific range, like by default between 0 to 1. So that is the normalization method. In the min-max scaling, it is done through the mean value and the max value of the feature. Now, if you want to scale any value of the feature called the scale value, if it is z, then z is calculated as x minus mean by max minus mean. For example, if you want to rescale the value 20 to this default range between 0 to 1, then if the mean value is 10 and the max value is 30 for that particular feature, then z is calculated as 20 minus 10 by 30 minus 10. So that will be 10 by 20 is equal to half. So you see that is now falling between 0 to 1. Now the disadvantage of this technique is actually suppressing the outlier. Let's say you have a trained data, right, to fit this estimator method or this scaling method. In that data, whatever is your mean value and max value, in your test data where you transform that to the rescaled value, there if any value, if it is original value is greater than or lower than that mean and max value, then that is called outlier, and that is very difficult to bring in this 0 to 1 range. That is done through the clipping technique, but that is that suppressing of that outlier. Another drawback of this method is like over compressing the all value between a very small range 0 to 1. Now the application of this scaling method is mostly on the image processing. That means you have some RGB value and you know that RGB value should always be between 0 to 255. So you need to scale all the pixel data value to this 0 to 255 range. So that is done through this min-max scaling in the image processing algorithms. In typical neural network algorithm, the data is required to be in this range 0 to 1. So that is also done through this min-max scaling. Now let's see one example using the scikit-learn pre-processing library and calling that MinMaxScaler method to see how my data is rescaled to this 0 to 1 range. Let's first import the MinMaxScaler for scikit-learn preprocessing library. And let's define a MinMaxScaler from this imported MinMaxScaler. And I have not defined any property, though it has very bare minimum parameters to pass. Let's see what are the default parameters. So you need to write MMScaler get params, and then you can check what is the default parameter. So it has basically two parameters. One is clip, so that I will explain how you can handle the outliers using this parameter, and second is feature range, so that is 0 to 1 by default. You can change it to 0 to 255 in case of image processing or any other requirement if you want. Let's create a data like training data xtrain is equal to, I just define a matrix, so it's a like very simplistic matrix, and we have like 3 rows of it, and then I will fit my MinMaxScaler to this data. And I just give the transform method to get the value. Let's define one test data as well. So initially I will just keep the copy of my train data to my test data, and I will transform my test data using this MinMaxScaler which is fitted on the train data. And you see now every value of both the features are within range 0 to 1. Now let's define one outlier here which is above the max value of my train data. Let's see what happened. You see, for this case, it is not falling within that 0 to 1 default range. How can I fit this outlier within my default feature range? So let's enable the clip property. So if you enable the clip property, then it will clip the outlier. So now my clip is true and feature range is 0 to 1. Now if I, so now using the clip, I can suppress the outlier. Just bring to your attention that this is suppressing, like this is somehow handling the outlier. But if you have too many outliers, this value will not give you the clear picture, because everything it will clip and try to fit within that range. So it's not correct, right? So if you have too many outliers, don't try to use the MinMaxScaler. Thank you so much for watching this video. Please leave a like and subscribe for more videos like this. If you have any doubt on this topic, or if you have any further question, please leave it in the comment section below. Thank you so much. See you again.